Hey everyone, welcome to lesson 1.2 of theme 5 GCSE Geography. So as a starter and a refresher on what we discussed last lesson, here's the graph that I was talking about. So you'll see all of these peaks here. This is an interglacial, 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 interglacial along a time scale that stretches back 1,000,000 years. Okay, so these are then the glacials, the ice ages in between. Now this is where I've stuck my labels. As long as these three are pointing to any of these warm peaks, and these three are pointing to any of the cold dips or troughs, that's fine. You might have chosen different ones to the ones that I've pointed at. So when the tilt is less, you get more solar radiation, it's an interglacial. During interglacials, there's sometimes short periods of cooler temperatures. This is sometimes called a mini ice age. It does happen. And interglacials are normally much shorter than glacials. Glacials can last up to 100,000 years. Interglacials, like I said, are normally 11 to 15,000 years. When it's more elliptical, when it's more wobble, when it's more tilt, that's when you get ice ages. Okay, so just check your graph from last lesson and see that it lines up with what I've got here. So those are the natural causes of climate change, those three things: sunspots, volcanic eruptions, and the three changes in the Earth's orbit. What we're going to move on to today, of course, is mostly what we talk about recently, which is human causes of climate change. So you're going to be drawing a diagram of the carbon cycle, so this will have some overlaps with science. We're then going to look at how human activity affects the carbon cycle and therefore ways in which we are messing with the natural greenhouse effect to cause an enhanced greenhouse effect that we also know as global warming or climate change. So pause the video here a moment, get down the title, and we'll get going. Okay, so first up, what links all of these images together? Just have a little think. You don't have to write anything down. It's carbon that links all of these things together. Carbon is one of the building blocks for life. It is in all living things. That includes us, vegetation, vegetables, leaves, coral polyps. It's in fossil fuels, coal, oil, and natural gas. And when you process some of these materials under enough heat and pressure, diamonds are actually created through extreme pressure being applied to carbon in a natural setting over a period of time. Fossil fuels like oil that we then burn, coal and oil and natural gas, and that releases the carbon dioxide. Carbon molecule mixed with two oxygen molecules. Carbon di meaning two, oxide meaning oxygen. Carbon dioxide, CO2. It's also the graphite in your pencils. So carbon is one of the building blocks for most things on Earth, especially living things. We're going to use a lot of key terms today. Okay, carbon sink. You've heard this a little bit in Year 9. It's anywhere that carbon is stored for a long period of time in a natural setting. So trees, forests are carbon sinks. When trees photosynthesize, they take in the carbon dioxide and lock it away, and they release oxygen. So that is a carbon sink. Fossil fuel stores under the ground, coal seams, that is a carbon sink. The greenhouse effect, this is an entirely natural process. Our atmosphere behaves like the glass on a greenhouse. It lets enough radiation in from the sun, it traps just enough and releases just enough back out to space to keep Earth warm enough for life on our planet to survive. It's when you get an exaggerated greenhouse effect, because we, through burning fossil fuels and creating climate changing gases, we are making the glass of our greenhouse, we are making our atmosphere too thick. So too much heat is trapped and it enhances the natural greenhouse effect to a man-made level. Greenhouse gases, long and short wave radiation, and fossil fuels. So pause the video here a moment and copy those down, please. Okay, let's talk a little bit more about this greenhouse effect, all right? Now, the greenhouse effect is perfectly natural and is essential for life on Earth. The greenhouse in your garden, it means you can grow things that need warmer temperatures, like tomatoes, because what happens is the glass allows solar radiation in from the sun in the form of short wave. Let me get this the right way around. Yes. in the form of shortwave radiation. It comes in through the glass and it then reflects off the surfaces inside the greenhouse in the form of long-wave radiation, which is heat energy. So it gets nice and warm inside the greenhouse, warm enough for stuff to grow. Just enough heat escapes from the greenhouse so it doesn't get too hot. And that is exactly the same way that our atmosphere behaves. Hence, we use the phrase greenhouse effect. The upper layers of our atmosphere behave just like the glass on a greenhouse. They let the shortwave energy in from the sun, and it is then reflected off the Earth's surface in the form of heat energy, and it warms up our atmosphere, keeping temperatures on our planet perfect for life on Earth to survive. But crucially, it lets plenty of that heat energy radiate and escape back out into space. It traps just enough. A perfectly natural balance, the greenhouse effect. The problem comes when you get an enhanced greenhouse effect because we are messing with the thickness of the glass. We're messing with the thickness of the atmosphere. And that's because we're messing with the carbon cycle. Now, what we've got going on here is a mixture of natural and man-made carbon usage. All right? So if we look first at just really what's going on in this inner circle, okay, the light pink. What happens is carbon dioxide from the atmosphere is taken in by plants. When they photosynthesize, they take in carbon dioxide and they release oxygen. And that carbon gets locked away in the trees and in the vegetation. It moves from being inside the vegetation to being inside other things in two ways. Either that vegetation dies or animals die, and over millions of years and lots of pressure and lots of other complex processes, it becomes a fossil fuel locked away underground. Coal is fossilized plants, oil is fossilized animals, very, very simply put. Okay? So sometimes that stuff will decompose and rot into the ground and become a fossil fuel. Or the vegetation gets eaten by animals, and then the carbon goes from the plants into the animals, and it's released from the animals during respiration, during breathing. We breathe out carbon dioxide back into the atmosphere, and then it gets drawn back into the plants to either create fossil fuels millions of years ago or to be consumed again by animals, and respiration releases it again. And you have this natural cycle of carbon going on, building blocks for life, natural levels of it in the atmosphere. Where things get messed up is when humans come along and we mess with the carbon stores. We either dig up fossil fuels that's full of carbon and we burn it, and that releases massive levels of carbon dioxide into the atmosphere, way and above what would naturally be being released by respiration of living things. So we've got this accelerated release of carbon dioxide because we're burning the fossil fuel carbon store. Or we've also got accelerated release of carbon dioxide when we slash and burn our rainforests to make room for agriculture, because this is having an effect in two ways. Number one, you're cutting down a carbon store, a carbon sink. So there's no trees to absorb the CO2 in the atmosphere. Number two, when they're cut down to clear the area, they burn them, slash and burn. And that releases all the carbon that was stored away. So this carbon cycling going on, nice greenhouse effect, no problem. Humans causing accelerated release of carbon dioxide from fossil fuel carbon stores, from vegetation carbon stores, and then also removing the store of vegetation as a carbon sink. We are releasing way more carbon dioxide into the atmosphere than can be naturally absorbed by the carbon cycle. What I'd like you to do as best you can, pause the video here and make your own version of this diagram in your books. Take a full page, take your time, break it down. Okay, so let's look at how humans are making a mess of it, basically. Two ways in which the carbon cycle could be affected by humans. Burning fossil fuels, so we've dug up the coal, oil and natural gas, and deforestation. We are removing forests for so many reasons. Slash and burn for agriculture, like I mentioned, but also to clear room for urbanization, the growth of our towns and cities, and lots of other reasons that we'll come on to later in this theme. I'd like you to explain how these two human activities will change the carbon cycle and ultimately mean that there is more carbon dioxide in our atmosphere. So I'd like you to copy and complete these sentences close to the diagram you've just drawn. Burning fossil fuels would change the carbon cycle because... Basically what's happening is all the carbon that was stored in the fossil fuels under the ground is then released into the atmosphere as CO2, increasing CO2 levels in our atmosphere. Deforestation would affect the carbon cycle because 2 ways. First of all, you cut down the trees, which removes a carbon sink. So all of the carbon dioxide that would have been absorbed by those trees remains in the atmosphere, increasing CO2 atmospheric levels. Secondly, when you cut down the carbon sink, when you cut down the trees, they're often burnt to get them out of the way, to use the land for other things. So that is a really rapid release of all the carbon that was stored in the carbon sink, that was stored in the trees, and it's released into the atmosphere, again increasing CO2 atmospheric levels. So pause the video here a moment, listen again to what I've just said if you need to, and copy and complete these 2 sentences to go with this diagram. All right, so let's bring it back to the greenhouse effect that we were talking about earlier. Human activity and the greenhouse effect. How is human activity bringing about climate change? So we know that it's warming our climate. We used to call it global warming, but that became a misleading term because everyone thought, oh, the world's going to get nice and warm, we'll have great summers, yay. Actually, no, it's far, far, far more complicated than that. It actually means more storms. It means some areas, in fact, will get colder due to changes in ocean circulation. It means more hurricanes. It means more flooding. And it means more drought and more heat in areas that are already very, very arid. So in summary, it causes extremes of temperature and extremes of weather and very unstable weather and climate. So we've moved a little bit from calling it global warming to calling it climate change now. But you will hear global warming and climate change being used interchangeably. They're the same thing. Human activity and the greenhouse effect. So this greenhouse effect here, minding its own beeswax, human activity is causing carbon dioxide levels in the atmosphere to increase. This means the upper layers of the atmosphere become thicker. Therefore, when the shortwave radiation enters and is reflected off of the Earth's surface as long-wave radiation, which is a little bit weaker in terms of power, instead of plenty of heat energy escaping and only just enough being trapped to create livable temperatures on our planet, the atmosphere is now too thick with greenhouse gases, such as carbon dioxide. And this means not enough long-wave energy escapes, too much long-wave heat energy is trapped, and this is warming up our atmosphere. And as our atmosphere warms, so do our oceans, and this is bringing about all kinds of problems. Okay? And that's how humans are causing climate change. We are causing an enhanced, an extreme greenhouse effect because of the greenhouse gases that we are releasing, primarily carbon dioxide, but also others such as methane and things like that we'll discuss in more detail later on in this theme. So put this subheading, print out and stick down this diagram. If you don't have a printer, you could either leave a space and we can sort it out when we come back, or you could attempt a hand-drawn version if you think you can, and then re-listen to what I've just said and explain how the deforestation, the urbanization, the burning of fossil fuels, increasing CO2 levels, thickening the atmosphere, and therefore too much long-wave radiation is trapped and we're warming up. Okay? And that brings you to the end of lesson 1.2. So we've only got one more of the additional 3. So we've got 1.3 to go, which is evidence of climate change. What's the proof? Everyone's talking about it, but how do we know it's actually happening? What's the scientific evidence? So we're going to look at proof of climate change, and then it brings you into lesson 4, the atmospheric circulation after that, which is the one that was already ready on Moodle. So you'll be back to the normal sequence then. It'll say lesson 1. Or I might change the title to lesson 1.4 to feed you in. Okay, if you have any questions, give me an email, gleesona@hubcymru.net. Otherwise, I'll see you soon for Evidence of Climate Change, lesson 1.3.